we're going to look at a few different concepts and expand on the Pythagorean theorem in lesson 33. The first one, I want to refresh on simplifying the radical and then add one step to it. If we're solving for example 1a, and it says simplify the radical, and we know it's a right triangle because of the right angle sign, we can do 5 squared plus 5 squared equals x squared. We get 25 plus 25 equals x squared, and add those together for 50 equals x squared. Square root, this stuff that we've been doing. Simplify the radical. So we got square root of 50 equals x. So we do square root of 50 and look at its factor tree. What are some factors of 50? Well, 10 and 5, and 5 and 2. Those are the same, so they can come out as 5. Take the 5 out, and then you're left with radical 2 equals x. That's just a refresher on simplifying the radical. Now let's look at one that's a little bit different, a little bit extra to it. We have 5 radical 13 squared as the hypotenuse, and that equals 6 squared plus x squared. Well, what we're going to have here is, let's go ahead and do 6 squared, 36 plus x squared equals, let's look at how we do this. If this whole thing is squared, then you have to square both numbers. So I square the 5 to get 25. When I square the square root of 13, I get 13. Now we multiply those together to get 325. 325 equals all this. Subtract 36. 325 minus 36 is 289. That equals x squared. Square root it. Square root of 289 is 17, and that's nice because now we don't have to simplify a radical. It is a perfect square. So x equals 17. But that is how you do this situation. That's kind of what that was for, just how you do that algebraically. Now let's look at the converse of the Pythagorean theorem. If you remember converse, well, let's look over here. If you remember, converse means if Q, then P. And so what is the conditional statement though? Well, the conditional statement, if we're talking about Pythag, is just if you have a right triangle, then a squared plus b squared equals c squared. This is backwards. This says if the sum of two squares equals the hypotenuse squared, then it's a right triangle. So in example 3 it says determine whether each triangle is a right triangle, but we don't know, so we're trying to figure out if it's a right triangle or not. We know all three sides, so this is where it's the converse. The converse is we're going to do the two shortest legs squared equaling the hypotenuse squared. Hypotenuse is always the longest side, that's why we know it's 12. So then we look to solve 16 plus 121 equals 144. Well, when I add 16 to 121, that comes out to be 137, and it does not equal 144. So therefore, this is not a right triangle. And we solve that using converse of the Pythagorean theorem. Now let's look at B. and we'll try to solve and see if this is a right angle. So we take our two smallest legs, 5 squared plus 12 squared equals 13 squared. And then from there, we see if it works. 25 plus 144 equals 169. Add those together to be 169, and it equals 169. Therefore, it is a right triangle. So that's how you use converse of the Pythagorean theorem. You simply work it backwards. We see if it does fit into the Pythagorean theorem. One more concept in this lesson is the Pythagorean inequality theorem. What this states is if a squared plus b squared is less than c squared, then the triangle is obtuse. Or if a squared plus b squared is greater than c squared, then it is an acute triangle. So in example 4, it wants us to, the instructions are determine whether the triangles are obtuse, acute, or right. And so we simply plug them into the Pythagorean theorem. Once again, smallest legs are what you do the sum of, and the longest leg is hypotenuse. So we do 16 plus 80, that's not, the square root of 8 squared is 64, equals 81. Add these together and get 80. Well, that does not equal 81, it is less than 81. 80 is less than 81. So therefore, if my two sides, if their sum is less than hypotenuse, then it's obtuse. So this is an obtuse triangle. And that would be the answer for A. And we do the same thing for B. Take our two smallest sides, set them equal to the hypotenuse squared. 25 plus 36 equals 49. 25 and 36 is 61. That's greater than the other side, excuse me. So if a squared plus b squared is greater than c, if a squared plus b squared is greater than c squared, then it's acute. So it's an acute triangle. And that's how you do the converse of the Pythagorean, inequality in the Pythagorean theorem.